Yeah, so since the inception of the blockchain, it's come about with many amazing solutions, one of which is decentralized finance, which is powered by the DeFi theory. But to understand what the DeFi theory is, we probably need to get a little bit of an overview of what decentralized finance is. Okay? Let's take a look. Decentralized finance is simply a financial system that eliminates what's called intermediaries. The need for a third party to oversee transactions or to oversee exchange between two people. In this case, it could be guarantors or banks. Okay, to make it happen, the blockchain has been leveraged using cryptocurrencies like head of Dogecoin or Ethereum or Bitcoin and things like that, right? The second important thing that makes these things happen is called a smart contract. Okay, so I'm just going to show you a little bit of an illustration of how decentralized finance works. There's a need for an intermediate.
Helps these things happen and makes sure that you can trust that these things are transparent. But we have decentralized finance, which is much more simpler, much safer, more transparent, and the technology that powers this is really interesting. So you see that little diagram in the middle. That's actually the blockchain. That's a smart contract. You already know what a contract is. If you came last week, you probably know what a smart contract is. You know, it's just the guy. It's code that you can see that is making these things happen. No need for banks that can cheat you or whatever, right? Next slide. Yes. Now that you understand what decentralized finance is, we will be talking about some important keywords that will help you know or understand the DeFi theory. The first is liquidity, liquidity pools. There's market makers, automatic market makers, XYZ model of pooled liquidity. You don't need to remember these words. I'm going to share my slides, but I'm just going to be walking you through what some of these things mean. So next slide. I have this diagram that sort of helps to explain how liquidity and what liquidity pools are all about, okay? Liquidity is just simply readily available tradable assets, okay? It could be money, it could be crypto, it could be NFTs, it could be your shoe. If all of you come together and bring all the shoes in this house and go and drop somewhere, it's now what? A liquidity pool of shoes. So a liquidity pool, as you probably already know, is just like a group of, or a gathering, or a collection of assets, okay, tradable assets that people just come to, as you can see here, interact with. So you have lenders, okay. If this entire section decides to donate all their shoes to the liquidity pool, you would become what? The lenders. Your job is to provide the shoes that people are going to be wearing. Now, how do you make? How does this work? Why is this entire section going to bring out their shoes and give everybody else, right? Transaction fees. You've heard about them. You've seen them in some places like Uniswap. You probably didn't know that you're actually paying people. People are providing the money and the liquidity that you use to sort of exchange coins, swap coins, or do whatever you want. So when you pay Uniswap some amount of money, you're also paying the lenders, the people that are providing the liquidity. Now you have lenders, like I said, providing assets, and then you have borrowers, people that are sort of exchanging. So if you come to the Uniswap, for example, if you want to buy Zend, okay, you probably have to drop some Ethereum. So that's actually what? Collateral. It's literally you borrowing it. So if you don't come back and return the Zen or whatever, they have your Ethereum. It's all good. It's like literally a bank, but this time you don't have somebody in the middle that is can even manipulate it or can even be biased by race or some other things. So that's all about liquidity pools, right? Before I go to the next slide, I want you to know that the lenders in this case are also called market makers, and I'll be going into more detail in the next slide. Next slide. So I've covered liquidity and liquidity pools, right? Next up is market makers. Okay, you've probably maybe one person or two people, because it's not very common, has heard about market makers, and it's like, what is this? What does it mean? And why is blockchain just stressing me out, right? Market makers are the lenders that you saw in the previous slide. They provide liquidity. Okay, you have market makers in the currently existing financial system. They are banks. In the forex market, you have banks or you have institutions, very, very big people coming to just drop a lot of money or provide liquidity or assets and things like that. Those are market makers. That's what you already have in what traditional financial systems and even in centralized financial systems, okay? Even the ones that run on the blockchain. But at the end of this conversation with you or discussion with you, you're going to understand how DeFi Theory has helped to sort of upgrade this market making system and create what is called an automated market maker. So I'm going to be walking you through that in next slide. Yes. First off, I want to sort of shed some more light on what market makers are and what the point is all about. So you see this rotating cycle, right? You see the market maker is providing liquidity to a participant, somebody that comes to the market or to the exchange like Uniswap to what? Collect some money or some tokens or something like that. And these people are actually passing out the risk. So what do I mean? The risk of trading on this platform back to the market makers, and in return, these market makers get some form of transaction fees, right? So what is the risk? I think a month ago or something, a lot of coins crashed. The crypto coin market was in shambles. I have a friend that lost half of his portfolio because of a tiny dip. Okay, so that is the risk we are talking about. These people come and provide Ethereum or Zen or some kind of Bitcoin or whatever, and you're coming to borrow their money or move their money from one place to the other. If you mistakenly go and move Ethereum and it rises, and you dropped for them Zen and Zen falls, that is the risk they are taking. Okay, so you're literally providing, abstracting risk, giving risk to them. They are the ones that are now taking the risk of if the market rises or if the market falls, I'll be in trouble. Okay, that's a little bit of how the relationship between market makers and participants work. Same as typical banks and all of that. So next up, we're going to talk about automated market makers. Very important, very awesome innovation that came about from the DeFi Theory. This is, finally, we are going to see small maths. Sorry, but this is a very simple equation that is literally in charge of making Uniswap work. X times Y is equal to K. I'm not going to go too much into detail or go too technical. I don't like maths either. But the entire point of how automated market makers work is literally controlled by this very tiny equation at the bottom of the screen. So let's see what it's about in the next slide. So what it's literally saying is that if you come, before I'm going technical, if you come to Uniswap, okay, how market makers, people that are coming to sort of put in their money so that you can trade, so that you can do business, okay, what they do is that they drop, if they are trying to provide liquidity, they have to drop 2 tokens or 2 coins or 2 currencies or whatever. So if they are providing liquidity for Ethereum, they will have to provide Ethereum against Zend, or Ethereum against Polygon, or Ethereum against Bitcoin. So there has to be sort of a ratio. So if they decide that maybe Zen, for example, could be a liquidity provider, if Zen comes to Uniswap and says, I want people to be buying Zen, they provide liquidity because like they created a coin and they have liquid Zen, right, available. If Zen Finance wants people to be buying Zen or exchanging it for Ethereum or whatever, they are going to dump a certain amount of Ethereum and dump a certain amount of Zend. Zend is a coin, if in case you didn't know. Okay. Now, whatever ratio that they've initially dumped into Uniswap or whatever decentralized finance that you see is going to become the standard for how these coins are exchanged or are traded on the market. So if Zend, because they are not mad, comes and drops 1,000 or 10,000 Ethereum on on Uniswap, which is a lot of money, right? I don't want to do the maths. I don't really like maths. Anyway, and they decide that one Ethereum should be worth maybe 1,000 Zen, because obviously Ethereum is really high and all of that. It means that if they dropped 10,000 Ethereum, the amount of Zen would be 10,000 times 1,000, which I honestly don't know right now, probably 10 million or something. So the point is that they have created a ratio, they have created sort of a rate, okay? If you have 1 naira equal to $1, when these people will come and drop this liquidity, they have essentially created a currency rate, okay? And to represent this currency rate that I'll be explaining to you, this equation comes to play. So remember that I told you that Ethereum, Zen Finance came and dropped Zen, okay, and also dropped Ethereum, and this created a ratio. So if they dropped maybe 1 Ethereum and dropped 1,000 Zen, it means that for every 1,000 Zen you can get 1 Ethereum. That's the ratio they've created, okay? And like I said, represented by this, where the token X, we could just call it Ethereum, okay? Token Y, we could just call it Zen, is equal to a constant, which is what? A ratio. So if you say, if you are trying to find how many, let's say this is Ethereum, X is Ethereum and Y is Zen. If you're trying to find how many Zen you can get by dropping 1,000 Ethereum, you would just do some maths, divide K by the amount of Ethereum, and you get the amount, the corresponding value in Zen. It's some maths. You see some more later. But the entire point is that there's a mathematical equation that's powering this. And I'm not trying to go too much into detail, but it's really interesting. There's some extra logic that you can probably read out or ask me on Twitter, and I'll share with you. That makes this not just possible, but really awesome, and makes it so that you actually never run out of liquidity in Uniswap or whatever decentralized exchange. So even if I come, once I dump 1,000 Ethereum and I drop maybe X amount of Zen, there will never be a situation where this amount is exhausted. There's some maths, like I said, I don't want to go into it. There's some graph and some other stuff that's a little bit more complicated, but it's really awesome, and I think you should check it out, because it's probably going to be your next ticket to building a decentralized finance cash out or something like that, right? So anyway, let's break it down a little bit, if you don't mind. I'm going to give you an example. Yes. This is actually really simple. It's just that everybody hates maths and it looks weird now. But essentially, I tried to use this equation, X times Y equal to K, to sort of show you like what I'm saying. I just wanted to show it to you so that it's not like I'm speaking English. So X is the Ethereum liquidity pool. Y is the token. In this case, I used DAI, D-A-I, okay? So it could be Ethereum and Zen, it could be Ethereum and Bitcoin, doesn't matter. The point is, X represents Ethereum, Y represents another token, and K is like the constant, the ratio, the number that signifies what ratio that these currencies are trading against each other, okay? So if I have 1 Ethereum to be $100, that's the price of Ethereum, okay? And in this particular scenario, I'm interested in trading 10. I'm interested in providing 10 Ethereum and 1,000 DAI tokens. Okay, that's the ratio. I came to provide liquidity, so I have to put 2 currencies that trade against each other. So for me, I put 10 Ethereum and I put 1,000 DAI, and it gave me this constant 10,000. It means that any time that I want to calculate how much Ethereum I would get for putting maybe 500 DAI, or how much DAI I'll get for putting 1 Ethereum, this number 10,000 will come into play. Okay, so how does that work? What happens when someone buys 1 Ethereum from this pool? Essentially, it's it's a pool. Okay, so I want you to picture sort of a river that's sort of divided into two. Okay, on the left is Ethereum, and on the right is DAI token. Okay, so the law states that if you remove some water, because it's a pool, right, from Ethereum, okay, you have to add some water to the other side for balance. Okay, so that's essentially what the next line is going to do for us. I am removing, remember I'm trying to buy one Ethereum, okay, just one. I'm moving one Ethereum, and because I'm removing one Ethereum, I have to add an amount of DAI to the other side. That's how swaps work, right? You swap one Ethereum and get 1,000 Bitcoin. I don't really know the maths, but that's literally how swaps work, right? Awesome. So when I remove one Ethereum, I want to know, or Uniswap wants to know how much DAI I have to provide for this swap to happen. So we use this formula. I am aware of how much Ethereum I want to buy, but none of us, Uniswap and myself, are aware of how much DAI, the token, I have to provide. So that means that there's a constant Y. If you do some mathematics, that's what's happening right now. Remember that constant K, 10,000, is literally what's defining, is like a constant that's defining how swaps and trades are going to happen. So when we do the mathematics, 10 minus 1 is 9. You divide you divide 1,000. You do some maths here. There's maths happening, guys. Bear with me, please. So yeah, at the end of the day, we come to the conclusion that it's we need 111 DAI, DAI, okay, to get we need to provide 111 DAI to get one Ethereum. So that's essentially how swaps work. That's essentially probably how things around the entire decentralized exchange world happen. There's this XYZ model of pooled liquidity is a formula, and there's literally the Z has changed to K. XYK, let's call it XYK. But that's pretty much it. It's really awesome. If you have this overview, it's enough for you to sort of venture into attempting your own decentralized finance platform, your own swapping platform, not just copying code from some place. You probably understand now that if you take something from this side, you have to add something from this side. And yeah, that's all about DeFi theory. That's a very simplified version. You can probably Google some more. Mixing up Web 2 and Web 3 here will probably be around storing things that are not financial records or things that the blockchain didn't come out to solve, like, okay, consensus, which is basically agreement. Okay, so Alice says I should buy. Alice says she wants to send Bob. Alice says she wants to send Bob some money, right? So there's somebody in the middle, but it's not a person, and it's not a business. It's some code. Okay, and the code just makes that happen. So this is not going to be stored in Web 2. It's going to be stored in Web 3. Where Web 2 could come in is just providing a website, providing customer support, maybe logging, or what's called indexing records. I don't want to go too technical, but I would feel like, unlike the NFT space, which is a sort of currently still a mix of Web 2 and Web 3, and even Web 3 social media, this guy is most independent among all of these things. There's the only thing that you'd see that is sort of still in Web 2 is like user experience, like the website, but you can literally run the entire logic for making these things happen on the blockchain independently, and it will work fine and even fast. So this might not be the best use case for let's combine Web 2 and Web 3, because it's like it's been done, and it's been done very well. Okay, so a very good use case for combining Web 2 and Web 3, which is being sort of scratched. Nobody has done a successful one, is Web 3 social media. So one of the points of Web 3 is decentralization and censorship resistance. Basically, as it stands now, Twitter can ban you. or can remove your tweet and all of that. So we're trying to see a situation where nobody can do that, right? So in this particular space, social media, you can easily combine the user experience that you get in Web 2 and the decentralization you get in Web 3. There was something I was exploring some time ago. I haven't even built it, right? Because, yeah, I think I was busy. Instead of, there's something called finality. I don't want to become very technical. But essentially, because you don't want to have somebody sending a message and it's spending 60 seconds or 1 minute, because transactions take some time to record on the blockchain, you can actually, for me, you can take these transactions, put on a server, put them in what's called a queue, just one by one they are being recorded on the blockchain. But what the user is going to see is that immediately the person presses send, the message sends. So they don't have to see the amount of time it takes, which is probably 60 seconds, for this message to be saved on the blockchain. So you allow the Web2 server to collect these messages, put in a queue, and process them one by one. When that is done, that's what I mentioned about finality. When that is done, you now record on the blockchain. You can decide to remove the one in your server or whatever. The point is that you have sped up the amount of time it took to record this message, and you've also leveraged the power of the blockchain to make sure that to convince the user, to show the user that their stuff cannot be tampered with because it's now on the blockchain. So that's a better use case. It's not really DeFi.